welcome back. I think this is March 25th. This is lesson 8.3, which is on page 432 in your textbook, if you want to follow along. Today we're graphing quadratic equations in standard form, ax squared plus bx plus c. So now we have that middle term to worry about. Things that you already know. If a is positive, greater than 0, it opens up. And if a is negative, that leading coefficient is negative, less than 0, then that parabola will open down. Things that are easy to see from this equation is the y-intercept, which is located at that constant term. So if it's positive c, that's on the y-axis at whatever that number is, the sign goes with the number. So negative c, I take that negative sign with it. The axis of symmetry, which is the same thing as the x-coordinate of the vertex, is at negative b over 2a. b is the coefficient of the middle term, and a is the leading coefficient. If I need to find the y-coordinate of the vertex, we find that by substituting that value into our equation and solving. So, look at example number 1, which is on page 432, where they give you an equation and ask you to find the axis of symmetry and the vertex. The axis of symmetry is minus b over 2a. In this equation, the b is 8, so I would have negative 8, or wherever you want to put the negative sign, and 2a is 2 times 2, which is 4, and we reduce, so at negative 8 divided by 4 is negative 2. So I have an axis of symmetry when x equals negative 2. Remember, that's a vertical line. For my vertex, we have just found the x-coordinate. To find the y-coordinate, we're going to replace x in our equation with negative 2 and find the value. So I have 2 times negative 2 squared plus 8 times negative 2 minus 1. So I have 4 times 2 is 8 minus 16, which is negative 8 minus 1. So at negative 2 comma negative 9, I have the rest of my vertex. So we have an axis of symmetry, minus b over 2a. We replace that value back into our equation to find the y-coordinate of the vertex. Is this a maximum or a minimum? It opens up, so this will be our minimum value, and if we would have an equation, if you look down at the bottom on page 432, they have a little graph to show you what it looks like so that you can see. You can also check on your calculator that way also. Look at monitoring progress. Pause the video at this point and look at 1, 2, and 3. See if you got them right. I will work on here just in case you're not pausing. If I have number 1, 3x squared minus 2x, I'm thinking plus 0. So my y-intercept would be at 0. The axis of symmetry is minus b over 2a. That's also the x-coordinate of the vertex, so negative 2 over 6 is going to be positive 1/3. So an axis of symmetry at 1/3, I'm going to replace that into my equation. So you have 3 times 1/9 minus 2 times 1/3 plus 0. So 3/9 is 1/3 minus 2/3 is negative 1/3. And I've got a vertex at 1/3 comma negative 1/3. If I'm looking at the second one, you might as well just do these together. I know you're not going to turn off this video, so look. I have x squared plus 6x plus 5. Axis of symmetry is minus b over 2a. Minus b, negative 6. 2a is over 2. So negative 3 and x equals negative 3 is the axis of symmetry. That's also the x-coordinate of our vertex. So for the vertex, we already are halfway there. We're going to plug -3 back into that equation and solve. So I have -3 squared plus 6 times -3 plus 5. I have 9 minus 18 is -9 plus 5 is -4. So a vertex at -3, comma -4. And the last one is -1/2 x squared plus 7x minus 4. And again, we're looking for the vertex and the axis of symmetry. So the axis of symmetry is minus b over 2a. So -2 times 2 is going to be just -1. So I'm going to have an axis of symmetry at +7. That is also the x coordinate of our vertex. So the vertex, we're going to plug -1/2 times 49. You're going to take your calculators. Plus 49 minus 4. And find, I'm going to get my calculator. And find that that is 41/2. So the vertex is at 7, 41/2. Look at the top of page 433 in your book at example number 2. Again, we're graphing, so 3x squared minus 6x plus 5. This time, we're also going to describe the domain and range. So think about what happens. This is opening up or down. It's opening up. So that vertex that we find is going to be the minimum. So let's find it. Axis of symmetry is how we always start, and that's minus b over 2a. So that's -6 is +6 over 6. So I have an axis of symmetry when x equals 1. We also know that's the x coordinate, the vertex. So the vertex is 1, and I'm going to plug in. What a nice number to plug in. So 3 times 1 is 3, minus 6 plus 5. So I have 3 plus 5 is 8, minus 6 is 2. So I have a vertex at 1, 2. If we were graphing this, which I want you to do, I have an axis of symmetry at +1, so there it would come. I've got a vertex at 1, 2. It opens up. I've got a y-intercept at 5. So over here at another one, there's another one. So this little parabola is looking sort of like that. What do I know about the domain of any quadratic equation? Right, always a set of reals. Unless it's a word problem and you are restricting it because it doesn't make sense in the context of the word problem. For this one, it's just an algebraic function, so no restrictions. Domain is a set of reals. What do you know about the range? The range are those y values. Since this is a minimum, y has to be greater than or equal to 2, because that was the y coordinate of that vertex. So the range is y is greater than or equal to 2. The domain, set of all reals. Look at example of monitoring progress on page 433. We might as well do these together. Or, ideally, you would pause them and do them yourself and see if you're right. We're graphing the function and describing the domain and range. So for number 4, h of x equals 2x squared plus 4x plus 1. While we are away from school and on break, a long break, use your calculator and check. Plug that into your equation, do it by hand, and see if you are right. While we're doing it by hand, I know I've got a y-intercept at 1, so, y-intercept, 0, 1. I've got an axis of symmetry at minus b over 2a, so at -1, which means I have a vertex at -1. When we plug that back in, I have 2 minus 4 plus 1 at -1, so I've got a vertex at -1, -1. And if we graph that, I'll have an axis of symmetry at -1. Here's my vertex. I've got a y-intercept at +1. So over here, there's another so my parabola would look something like that. You would do it much neater and smoother. Domain, set of all reals. The range, y is greater than or equal to -1. Look at the next one, which is number 5. Where k of x equals x squared minus 8x plus 7. Again, we are graphing, so the y-intercept is positive 7, so 0, 7, I have a point. My axis of symmetry is minus b over 2a, so 8 over 2, so my axis of symmetry is 4. That's also the x-coordinate of the vertex. To see what the y is, we're going to plug it in, so 16 minus 32 plus 7 is negative 16, plus 7 is negative 9. So I have a vertex at 4, negative 9, and when we graphed it, I have an axis of symmetry at 4. At negative 9, way down here, there's the vertex. I have a y-intercept at 0, 7, which means that over here, 4 away, there's another another point at that same height. So there's our, whoops, forgot he was down here. Oh, whatever with that. There's my vertex, so I'm coming up, and I'm coming up, until those are my points. So what do we know about domain and range? Domain is the set of all reals, and the range, y is greater than or equal to negative 9. For the last one, negative 5x squared minus 10x minus 2. Y-intercept is always whatever the value of that constant term is. So at 0, negative 2, that parabola intercepts the y-axis. The vertex, axis of symmetry, first, is minus b over 2a, so 10 over 2 times 5, which is 10, so negative b, positive, over negative 10 is negative 1. I have a vertex at negative 1, I'm going to plug that back in, so I have negative 5 plus 10 minus 2, so positive 3 is my vertex. And when we graphed it, we have a y-intercept at negative 2. We've got a vertex at negative 1, 3, where am I going? And I have an axis of symmetry at negative 1. What do we know about this parabola? Because it has a leading coefficient that's negative, we know that it's opening down, so this time, that is my maximum. My domain is still the set of all reals. Eventually it would spread out. But my range, this time y is less than or equal to 3 because this is a maximum instead of a minimum. If we look at finding maximum and minimum values, we've sort of already talked about that. Look at the bottom of page 433. The y-coordinate of the vertex is the maximum value when that parabola opens down, and it's the minimum value when that parabola opens up. So that leading coefficient tells you what shape it is and tells you whether you're going to have a maximum or a minimum. Example 3, turn the page if you're following along, I hope you are, is on page 434. Tell whether the function negative 4x squared minus 24x minus 19 has a minimum or a maximum. Well, right away when you look at that, that leading coefficient is negative, which means that parabola opens down and that vertex is going to be the maximum. So when we're plugging back in, we've got an equation, negative 4x squared minus 24x minus 19. And you're looking for, well, they did it for us. So minus b over 2a. When they plug in, I've got 24 over negative 8. I'm going to have a vertex at negative 3, or the axis of symmetry at negative 3. And we're going to plug that back in. So we've got so far, our vertex is negative 3. We're going to plug that negative 3 back into this equation. missing an X, and find out that that maximum value is 17, because that was the y-coordinate of the vertex. There is a favorite word problem, so look at example 4. It's got a nice picture. The suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola, and they give you the equation with which it can be modeled, where x and y are measured in feet. And then they want to know, what's the height of the cable above the water at its lowest point? So what are they asking? They're asking for the vertex of the y-coordinate of the vertex. And so if you look at the solution, they found minus b over 2a using that equation and a calculator. And then they're substituting that back into their equation to find to find the y-coordinate of the vertex. Again, use your calculator. And they rounded, and it was about 203 feet at its lowest point. Look at monitoring progress together on page 434 down at the bottom. Look at number 7. Is that going to be a maximum or a minimum? When you look at the leading coefficient, it's positive. So you know that parabola is opening up, and therefore that vertex will be a minimum. And similarly, if I look at the next equation, because it's negative, I know that's opening down, and that vertex, the y-coordinate, will be its maximum point. And then find the value, so I'm doing minus b over 2a, and for number 7, 8x squared minus 8x plus 6 minus b over 2a is going to be positive 8 over 16, so 1/2. And 1/2, when I plug it back in, I'm going to get 8/4, which is 2, and 8 minus 8/2, which is 4, plus 6. So 1/2 comma 4 would be my maximum value. And if I look at h of x, where it's negative 1/4, x squared plus 3x plus 1, I'm still doing minus b over 2a, so I have negative 3 over 2 over negative 1/2, which is positive 6. So I have 6, and when I plug that back in, I have negative 1/4 times 36, so negative 9, plus 3 times 6, so 18, plus 1 is going to be 10, so it's 6 comma 10. That was negative, so that's going to be my maximum. That's going to be my maximum. And then look at number 9. That's a calculator kind of problem. So again, minus b over 2a, negative 0.46 over 2 times 0.00016. Do that division and then plug that into the equation to find your maximum. Maximum. That answer should be 176. 176. If we look at the next page on 435, another little word problem. They give you a graph in one situation. So a group of friends launching water balloons. The function represents the height of the first water balloon, so negative 16t squared. We will see that a lot because that's a gravity, related to gravity, and we live with gravity, thank goodness. Plus 5, so there's one that they called f of t. And then the height of the second water balloon, t seconds after it's launched, is shown on the graph to the right. And the question is, which balloon went higher? So to figure easy to see on the graph what the maximum point is, for this one, it's negative, so we know we have a maximum, and we have to calculate it. And so they plugged in, they did it all by graphing. So follow it with your calculator, plug it in into your calculator and compare the graphs. So notice that the second water balloon was about 125 feet, and this first water balloon looks like it's a little less than that. If that's 150, each one is about 25, so it's about 100 feet, and second water balloon went higher. If you were going to trace, after you've graphed, remember you can use your trace function and until you get to the maximum, or you can go to your calculator and look for the maximum, which is second calc after you've plugged it in. Second trace. And look for maximum number 4. And again, you have to be a little to the left, a little to the right. Remember that you are reading left to right, so a little to the left, a little to the right, and my maximum would be what you're looking for right there at the point. Monitoring progress, I'm going to leave to you on your own. Number 10, the answers for those. I think I didn't even, I'm leaving those to you. Tonight's homework, this is for March 25th, are 3 worksheets in 8.3. These are located in your topics. If you go to assignments and click on that, there will be labeled worksheets. You are to fill those out and send a PDF form up to me. Also, save your paper because, just save your paper. If we all get back together, I'll be looking at your notebooks to see what you did, as well as, I'm not really grading your homework ever. I need to see that you did it. And that's all this is trying to do. You still can practice on homework. I don't know what we're going to do about quizzes. That's not the important thing right now. Mainly just get the information. Tomorrow's homework is not a video, thank goodness for all of us. You are looking at, in your textbook, problems 1, 2 through 36 even, 37, 38, 42, 45, and 50 through 53. Those are listed in the assignment, so they're on the board, and I read it, so you'd have it. You can always replay it, or you can just go look online at my school app. And that concludes section 8.3. Thank goodness.